I tell you in advance, I put the dregs of my paper cup drink in my back pocket. So when I turn around to walk off stage, the fact that I've got a wet bum was my drink. I kind of wanted to get out, like one of you was going to mention it if I hadn't, so there it is. Last year, when I was doing some of the emceeing here, we had a George from Love Holidays speaking down in the Queen Charlotte room. And I said something along the lines of, he uses the power of Go to send us on holiday, which is very kind of him. With our George today, George Kampanos, he uses the power of Go to make chicken delicious. So currently, Nando's uses about 50% Go and 50% Rust, and George has been on the Go team for the last 2 or 3 years. So please give him an extra big hand to the stage. George Kampanos, everyone.
Hey guys. Oh, that's not going to work out. Hi everyone. Thank you so much for having me. This is very special. I think David was saying in his talk how that's like third GopherCon, I think. This is my first, and I'm straight into the deep end, I guess. So let's hope I can swim. My name is George. I'm a software engineer at Nando's. I've been working there for the past 3 years, primarily Go. We do quite a bit of Rust as well. And when I have free time from taking care of the dog, which is another full-time job, I'd like to race go-karts or whatever can go fast. There we go. So as a little bit of context and a little bit of what this talk is about, this initially was like a 20-minute thing, just how I use Go to open a door, and we'll get to that later. But they said, you have an hour, so I decided to just go and just tell you everything about it, to tell you everything around this door. So if you're ready, let's go for it. If you haven't understood already from my accent, I'm not from the UK originally. I grew up in Greece. I grew up in a very small place. The main town was about, 10,000 people. And there's one gym there, and we're good friends with the gym owner, George, also, because everyone in Greece is named George, I think. And he's been running the gym for years and years, like 2 decades probably at this point. And when I was there for holiday, he told me that he wanted to modernize the business for many reasons. One of the problems that he was having was that newer, younger members, they were feeling a bit shy to go to him and ask for memberships. But also because everything was done on pen and paper, like new members and memberships, people that were working the evening shift, they had no idea who was who, essentially. So they needed something, they needed an app. He said, I'd want an app to be able to manage all of this stuff. So we went for coffee because, again, that's a very Greek thing. We go for coffee for hours and we talk about things. And we came up with a list of requirements of what this app may look like. And apparently I have a laser. It's a lie. So they needed an admin portal to be able to view and manage the memberships. They needed something like a mobile app so people can sign up and pay their memberships, renew it, etc. And they needed a QR code. The app had to produce some sort of a QR code because they had already purchased a turnstile door. So the app or this thing had to work with this turnstile. So I said, let's do it. Sounds fun. Because obviously, and I will say we quite a lot. It's because my best friend Spiros helped a lot with this. He's also a software engineer, but he is not in the industry. He decided to take up his dad's business, and he's still back home. And he was a great help, not just by helping with the code a little bit, but he was there to, essentially, he was my voice at the gym when I needed to ask stuff. So thank you to him. Unfortunately, he couldn't be in London because it's peak season in Greece and he's very busy. So again, I will speak about not just the door, but everything around that turnstile to make this last about 40 minutes. So initially, I started with an API, and it's just a simple RESTful API that is just providing CRUD operations to the database, which we'll get to later. So you'd have multiple UIs, like that's the app, that's the web or whatever. They need a centralized place to write to some database. It also provides a little bit of authentication, usually done with JWTs. So that's how I structured it. And because of scale, as I said, you have to remember scale is important here. We're talking about a very small app, or for not many people. So it's a monolith. I decided to go for a monolith and then say, if we hit any problems, we can break it down. So root folder, that has your command and your internal and your go mod and sum. The internal has all the stuff that you want to use. That could be your database, your payments provider, invoicing, whatever you call it, which can be shared only internally, I guess, with your code. And then inside command or CMD, you have the API, which has the main that starts the actual API, starts the web server if you want. And then members, memberships, each like resource, I guess, has its own file. The reason I did this is because then you can extract this file, you can take it out, and you can just break it down to multiple services if you need to, or if you find bottlenecks. I really enjoy interface injection because it allows you to take, say, the payment provider and stick anything there. Like you can do a real one, like you can have a Stripe, say, payment provider, or you can mock it, which is great for unit testing. And you pass it in to your handlers as an interface. So when you go to your main.go, you decide what you want to do. The real one, or when you go to your test, you can mock it. When a request comes in, we have, say, for example, a new membership request comes in. You have the fields that you want to do, and you have that you care about, and then you have a little bit of, I forgot the method name there. I'm supposed to say validate there, but it's fine. This is a validate method, essentially, and you check, hey, the title is required, and if it's not there, I need to raise an error. So this is the start, I guess, of the handler. You take the context, and you start. You check the roles. If it's a developer, an admin, those are the guys that can only maybe create a new membership. You decode the request. You do the validation. That's the method I was missing there. Whoops. And then finally, you go to your database, and then you return a little bit of JSON. If you're happy, you probably return the whole object. So this is it. It's very simple. I said it's like a very simple, crude create, read, update, delete API to just keep things together. Now, the most important bit is that we need a database. Regardless of whatever technologies you use, you need a database, and you need to, store members, memberships, etc. The gym is naturally relational, so you have a member having X amount of memberships there. Easy. But the problem is, how do you sync the database to the edge? How do you sync it with the door? And solution to all your problems, SQLite. Throw anything at it. It's great. But why SQLite? Obviously, it's relational, as I said before, so that's quite important. It's very fast because it's only a file, so you only write to it and you can read locally. You don't have to go over the wire anywhere. And it's just a file, so it's free. It's important. We don't want to, get the costs up for a small business. We don't want to give them a beautiful, Postgres cluster or whatever. Maybe we could beam the file to the door. The problem's single writer. Obviously, that's fine because we have a single API writing to this database, so that's fine for our case. And obviously, Seago. Seago can be a pain, where. So I'll show you how we do the migrations, and this is just a regular migration. You use Goose, which is a Go tool. It's great. Simple migration. You create the members table. You keep a connection open, and for now, I'll show you the connect local. You connect to the file. You use the database driver, the built-in Go one, and you return the connection so you can close it later. This is how you run the migrations with Goose. You select the dialect, which is libSQL at this point, or you can be SQLite, depending on the driver that you're using. And then finally, this is a generic method that I use to commit the transactions. So at the top, you just see how many rows were affected by the query you run. If there were any issues, roll back. Or finally, if you look at line 17, commit. And then the queries, say that's an insert query, you just write it as a const at the top of your file. And then finally, you just run it, essentially. You start the connection. You exec the query. If you look at line 7, check for any constraints. For example, you don't want to have duplicate members. And if there's any issues, roll back. Otherwise, commit the transaction, as I showed before. It's easy to unit test as well. It's just a file, and you can actually create an in-memory SQLite database. So you can, in theory, just for every test you have, spin up like an SQLite instance in memory, run the migration, so that has the added benefit of, hey, if I wrote a buggy migration, I can check it before I even commit the code. And then finally, happy path. For example, instead of the database that runs the migrations, you unit test your method, check the errors, and then if you look at line 26, you have a helper method to match what you expect. Similarly, on happy path, check for the errors using the errors aids, which is quite neat. Yeah, but we haven't solved how to actually use this thing. Like, it's fine because that worked on my MacBook, but how do you actually do it? And this is not a sponsored talk by any chance, right? But these guys are great. Turso, it's essentially a managed solution for SQLite. So it's kind of like how Google runs your Postgres. They take care of all the important things, which is it's probably safer than me beaming SQLite files around or keeping them in my local MacBook. If other instances connect to the same database, they eventually sync with master. So that means that I can have an instance somewhere on the edge, on the door, wherever, and once my API writes to master, or to the local instance that it has, and it syncs with Turso, Turso is going to do all the hard work of actually syncing it to the door. And you can set the intervals that you want to sync. So for example, it would be 1 second, 15 seconds, 30 seconds. And this is an overview of how it actually runs. So say a new membership is written, it goes to the local store, or the local database that you have, where you can go directly to them, to Turso. Eventually, that's going to get synced with the local Gimland database that talks to the door, and then eventually you send instructions to the turnstile to open. So this is amazing because, yeah, I don't have to do all the hard work myself. And it works out of the box because it's just an SQLite driver. So the only thing you have to do is actually just change a little bit the fields that you're passing. You need a connector and where you store the local file so you can delete it later. And then you just pass in the authentication token and how often you want the thing to sync. So, and the rest is kind of like handled for you, which is amazing. The rest of the code that I showed earlier just works out of the box. So this is it. SQLite to the rescue. SQLite solves all of your problems. Use it. It's great. I think we actually use it on Nando's. I was having this chat with someone, and we use it in production somewhere on Nando's, so maybe that's for another time. I'll just very, very quickly run through the front end, because this has nothing to do with Go. This is not like, I guess, a UX or UI conference. There's two things. There is the web app that they're using to manage memberships, Next.js, and we use something called Daisy UI, which is just Tailwind. It's just packaged nicely. And if it auths with JWTs, that's how it looks. I'm sorry, some of it is in Greek because they wanted Greek. It looks like this. You get basic information of your members. You can search, which is quite nice. It was important to them. See how many people, see if someone has a membership or not. And then finally, you get all the details for the member. You can create new memberships, and that's how it looks. And the app, again, I'm not going to go into too much detail. We wanted to build one app for both iOS and Android, save time and money. And yeah, React Native with Expo on top of it. Again, auths with JWTs. And we build and publish with EAS. That's how it looks. Basic. I mean, tell me about UX, please. This is a backend engineer's attempt of making something pretty. Killer feature, dark mode. They were great when they, we were showing them all this, and we were iterating with them, and they were like, "Oh, this is great." When I pushed the merge for this one, and they saw the dark mode, they go like, "Oh, this is a real app." Like, I don't know what's the psyche of people like. Yeah, so that's pretty much it. The apps are essentially a window to the API. They're just displaying relevant and hopefully useful information to members. Let's finally talk about the door. It took me about 15 minutes to get here, but let's finally talk about that door. So this is what it is, right? So I'm sure, like most of you, if you use the tube today, you probably used a version of this. What an access or high traffic access point is, by definition, is it has a shape that blocks the way, and you present something to go through. So if you use the tube today and you didn't jump through the barriers, you probably tapped your card, and it let you through. So this is a version of it. It's about yay big. It's like a small child size. And it had a, sorry if I go back, and it had a QR reader at the top where you can just scan it. Opens both ways. Obviously, we only care about the entry. But how do you wire this thing? I'm a software engineer, not an electrical engineer. When I went to uni, which way back, to one electrical engineering class. Sat through it and I realized I'm not smart enough to do this, and I left. So hopefully you can see the purple circle. So this is I guess this is the motherboard, if you want, of the door. And it has a lot of weird cables, but we care about these two, the RS485 connections. I'm sorry, to backtrack a bit. The first option is to use network. You can have either a LAN or a WAN connection to the door and give it instructions through either the internet or the local net. That wasn't good enough for that particular case because of how the gym was made. You couldn't run cables through there. It would be a trip hazard and stuff like that. So I had to come up with something inside the door. And as I said, the door provides an RS485 protocol, which you can pass signals such as open left, open right, etc., and everything can stay inside the door. The good thing is that you can buy off Amazon, that's an image from Amazon, of RS485 to USB. Therefore, you can wire a mini PC, which fits inside the door, inside the turnstile, wire the cables and have a USB, which means stick it into the mini PC, write all the Go that you want to open it. So finally, I went down there to wire it. So horrible cable, which I changed later, I promise, because we didn't want anyone to die. But essentially, you see the connection is there. That's the adapter over there. Hopefully, you guys can see. And then this is the mini PC. Actually, is like yay big. And an overview of how we actually, a bit better picture of how it looks. You have the door panel over there with the interface that talks to the USB, and the Go code in the database talk to Torso and to the rest of our to our services. The QR reader, which I didn't know before, when you connect it to a PC, comes up as a keyboard. And I'll show you the code about it later, but it's like plugging in any keyboard. It's weird, but worked. And we needed a Wi-Fi antenna, which is unreliable as hell. Sorry, side note, the internet in the island is horrible. We're talking about less than 6 megabits per second, connections, trash. And the dips that it does, unreliable as hell. So you cannot trust the internet. Should come in handy later. Oh, and we can connect to the mini PC via any desk in case something goes bad. Okay, let's write some Go. As I said, so we have a representation of a QR code or a QR image. So when the app generates that QR, it does some stuff about signing it and keeping it secret, but essentially it's just a JSON blob of membership ID, member ID. Line 7 over there is literally, you read standard in, because that's what the QR code, what the QR reader gives you. And you just wait for the new line. Every scan is a new line, right? Sorry, every scan ends in a new line. And you can just do all your parsing. For example, line 15, trim the space, whatever you need to do, unmarshal, and then write some logic to see if this is a valid membership or not. As I said, the internet there is so bad. So that's what SQLite is so good. You have the local file, and you can just read from it. So if the internet is down in the island, it means that existing members, they're not going to get locked out of the gym, which is good. New members, yeah, maybe they have to ask for, well, it depends on when the internet dropped. But it's good that, obviously, the database is on the edge. So you can run those operations, safely, I guess. And this is the juicy bit, I guess. This is what we all came for, but I'm sorry to disappoint you. It's very simple to do it with Go. It's literally, that's all it is. Lines 10, and then the struct over there, 18 and 22. These are all given to you by the manufacturer of the door. They tell you how to communicate with it. And then using the serial package to actually open a connection, maintain the connection to the door, or the serial connection. And then finally, if you look at the bottom, you just write to that. So it's like writing to any other buffer. which is wild because I thought it would be this, extremely complicated coding exercise, but it worked. Like when you see it actually, I think I've got the video there, we fixed it. So this is how it looks. The end result, as I said, is about yay big. We have Mike there protecting everything. Sorry, not me. And then we'll see my friend over there. There we go. So you go there, and it opens. So we open the door. 20 minutes for this, but yeah, like again, I haven't done this in the past. So when I tried it myself first, you actually see it. You scan it and it opens, and everything that happens in the background, it's crazy. Like it's extremely rewarding. Interesting side note. We were testing all of the code in that mini PC I showed before, and obviously it had a monitor over there. So everything was working, we stick it in, we tried to connect through AnyDesk to start everything, and we got a black screen. Yeah, but it was working literally 30 seconds ago. What the mini PC does, when you disconnect any, outputs or visual outputs, it just shuts down the graphic card. So when you connect to AnyDesk, it just, it's I don't have anything to show you because, so we had to find those VGA dummy plugs, which they are used for torrents. People that are seeders, they use this because I promise I'll use it for a good cause, not to, but yeah, they weren't available anywhere in Europe for some reason. I had to actually send them to Greece via post. I sent 3 separate envelopes with them. 1 made it. Don't trust the Greek post office. So yeah, all comes down to this. Like, it was very rewarding to see this, like, and especially that you can do it with Go, and it's so easy and so nice to do it. It's great because all those assumptions and all the stuff that you work on for the past, we worked on this for about 4 or 5 months. It's extremely rewarding to see it all come together and actually working, and it's actually reliable when the internet is down, et cetera, et cetera. So again, I had to fill a bit more time given I had the whole hour. So I'll speak about some other more meta stuff and how we deploy stuff. To the servers, it's very easy. I use something called Fly.io. Hopefully people maybe have seen those guys. They run their own infrastructure. It's like a cloud service, and they have the notion of machines. So your application runs into machines. Again, I only needed one machine, fine. And they make it extremely easy. You just provide this TOML file with all your configuration, what you want it to do, and it just runs it. The key part is line 17, where they have this smart thing that if your machine is not running or if it's not executing requests, it just shuts down, and it has Firecracker to just turn it on when the new request comes in. And this is key because you don't want to have loads of servers running all the time in an application that's naturally very low scale. So we're saving money to the business. But how do you deploy the door? Yeah, that was an interesting one because the door is somewhere that might not have internet at some point. So the fanciest bit on this is just a GitHub action that builds the application for Linux, because again we use Linux on the mini PC, and then magic wormhole to the mini PC, restart everything, and it works. If you have a better solution to this, I'm all ears because it's just horrible. So yeah, that's pretty much it. It's only 2 things. Like the Fly.io takes over like the web stuff, or and then the door is a bit more manual. Actually, get the GitHub action to build everything, but then manually send it to the door. And we have observability, because we're software engineers. We like observability, but it is important. But monitoring servers and web APIs and all that kind of stuff is a solved problem. Fly provides a Grafana dashboard. It's a solved problem. You want to see how fast it is. You want to see the load. Fine. You can pay either a lot of money or you can find free solutions. But how do you monitor the door? Again, similar problems. The internet is unreliable. What happens if there's a crash and no one can log in? Although everything is, how do you check for errors in the past? What if we have a bug and how do you know? The other interesting thing is what if people are trying to rig the system and they're trying to pass in like bogus QR codes? Hopefully, your application handles that, but what if you want to see a pattern? Because obviously we talk to the gym and they say, well, we see people like acting weirdly. Can you check this? And again, we don't want to spend money because for a small gym of maybe 2,000 members, it doesn't justify them. It doesn't justify the cost to have a Datadog subscription, right? Because that's the kiss emoji, because keep it simple, stupid. Try to make a joke. Yeah, but let's forget about fancy and expensive stuff. What if we just use a text file that then whenever we need it, we either check it on the device in the door, or we just pull it in our local machine and use good old-fashioned less and just check what's out there. Like, you could even take that file probably and stick it to Grafana or whatever, and it would do the job. And was it go 1 to 4, we get, or 1 to 3, we get slog, which is awesome. And then we use slog multi from Samber, which essentially allows you to not just print stuff on the console, but you can also print stuff in the file. So you can set it up. So you create your file at the top, line 8. Make sure that the file is created, and then if you look at line 21, you fan out your logs. So when you do slog.info, it goes to the it goes to standard out to the console, but also it goes to your file. And that's how they look. Not very sexy, but they work, because when an error comes through, you know it's there, and you can just get all the stuff that you need. The yellow stuff are, obviously I didn't want to get member information there. And then we use a very fancy incident management system called Discord. I'm not sure if you heard of it. Yeah, all the cool kids use it, don't worry. But again, we didn't want to spend money on something for errors that don't happen very often. But it works because they are familiar with Discord. We could put it on their PC, on the reception area, and when something happened, it was easy to monitor and see what was happening. We also did it for members that entered. So when you scan your QR code, they get a notification on Discord to say who you are. So if they don't know you for some reason, they can see your name, they can see your membership. So yeah, the whole point is just keep it simple. In this scale, in this context, it doesn't make sense to go and spend thousands of pounds worth of logging. And then finally, costs. Again, costs, I don't think I drove the point very well at the beginning of this. Costs are very important for this business. It's about business, right? So they don't want to spend crap loads on something that obviously is going to bring them business, but it's a small business. They want to keep it as low as possible, and it would be very hard to justify a $2,000, $3,000 bill a month for stuff that they never see. So we wanted to keep it cheap, and that was kind of the North Star, is how do we keep it as cheap as possible and minimize the costs. And it costs about $0 a month to run, which is great, because that's almost free. Obviously, there are costs associated to set it up, and I think there's a slide later. It's about $700 to set everything up, like Apple developer accounts. Obviously, Stripe takes a little bit of commission every time there's a new membership through the app. But what I showed you before, the core app, which is the API, the database, the door itself, it's free for them to run, which is great. And again, obviously, scale helps. Nando's different kind of beast. Obviously, you spend a lot of money, and I'm sure most of you guys working in big business, you expect that stuff to have a cost, but it didn't make sense to go fancy. So yeah, Fly is free. I think we go below I think they charge you after $5, so we use less than that. We were eligible for the free tier of Turso, but opted to pay because they wouldn't give you backups, which is a very smart business model. Because why pay if, yeah. And then the website is actually a static Next.js page on Cloudflare pages. There's a worker, and it just serves it, which is fine. They don't need anything more. The business email is just an info ad from Cloudflare, and then it just forwards to their Gmail. But also, I think is engineering choices. Again, we're so used. I think most of us, maybe again working in bigger companies, bigger business, there's like almost an infinite amount of money to spend. So we kind of go like, oh, we can try stuff, or maybe we don't care so much about what's that going to cost as long as it serves the customer. So, I think under strain or under weird or hard requirements, maybe we make different decisions, which I think they turn out to be good because they were able to make money out of the app and the door and everything from day one. Again, this is a bit of a breakdown to prove that we don't spend a lot of money. There you go, $2 on Fly. The right one is Torso, that we're free tier eligible, and then the last one is the EAS, the charge you for builds, but again, we fall below the free tier. Yeah, I just want to give a shout out to this MacBook and to the Go team, because most of the development for this was on this guy. So this is a 2015 MacBook Pro Intel. No issues whatsoever. If it wasn't for the app that you have to build it for within your processor and stuff like that, yeah, this MacBook Pro handled it perfectly. So shout out to the Go team. Like you don't have to spend a lot of money to get into development, which is great. So yeah, as an overview, maybe think about the cost. I don't know. Maybe think what would you do if this was your business? Maybe what would you do if do you need to spend the money? Maybe you do. Maybe you don't. I promise we're almost done. Let's talk about doors. Yeah, Go does serial. I walked into this knowing how to do maybe a third of those things. And it was an amazing choice to choose Go. I don't think I would have been able to get to this point without using Go. And it does serial. Like it's nice seeing it, or seeing one language from one end of the stack to the other. And yeah, loads of learning opportunities of how do you sync databases to the edge. Yeah, it was fun. It was so rewarding seeing, like when it scans. Again, I can't explain the feeling. It's like, oh crap, it's actually green after a few months. And then, yeah, finally, I think it's definitely worth trying it. Like if you have a friend, a smaller business, do some good. Like it's good, I guess, working for a business and pay the bills and stuff. But maybe we can use our amazing super power software engineer skills to do some good and help some friends. So that's it. Thank you so much. That's us celebrating after the scan I was saying before. So yeah, thank you. Questions or yeah?
Okay, so we should have loads of time for questions, should any of you have any. So yeah, hands up and I'll keep an eye out on the crowd as we go.
He'll get to you.
Hello. Just wondering if a Raspberry Pi would have worked inside the turnstile.
I can't hear you. If you can speak up a bit, I'm sorry.
Would a Raspberry Pi have worked inside the turnstile?
Yeah, it would. The mini PC, so to give you a bit of context, again, it's this very small place, right? And the gym is very good friends with the guy selling PCs across the town. Do you want me to keep answering? So yeah, I mean, it's a great question. So he told me, oh yeah, this guy's gonna bring us like the mini PC that we need, and it's not really mini, it's about yay big. And I was checking, and he charged him like 200 plus euros. And I was checking on Amazon. I was like, dude, I can give you like this size of a PC or like a Raspberry Pi for like close to nothing. But he didn't want to have a misunderstanding with his friend. But yeah, like any PC or any, I guess, board or whatever that can run Linux or that can run code, it would have done just fine. The other problem was, sorry, we had to, if you saw like on the diagram before, we had to install a Wi-Fi antenna because the guy selling the PCs, he didn't understand the concept of we can't have cables running through the gym. So when we turned it on, it's like, why that thing is not connecting? It's like, yeah, well, you got it. It was a mess. Sorry, maybe all the venting now is going to come out. And we have about half an hour of psychology therapy session here.
All right, next question.
There's one over there. It's closed.
I think it's on.
There we go.
Oh, it is. How often do you synchronize the membership data?
How often? So I've actually switched it recently as an experiment so that the API writes direct or talks directly to Turso instead of having the local file instead that syncs eventually. So the write happens almost immediately, I guess. And then the door syncs every 30 seconds, but you can set it to whatever you want. If you noticed before, maybe if I go back to the costs, Turso does charge you for it doesn't syncs. If you look at the third row, it does charge you for syncs. So if you had it every second, you had a bigger database, you might run out of that limit fast. But given the scale, 30 seconds seems fine. And then there's a bit of UI when you buy the subscription from the app that says generating QR code, which is a lie. It doesn't generate anything. It just waits for the door to sync. So 30 seconds seem to be the sweet spot in terms of cost and also usability.
Okay.
Yeah. Sorry, I can't see with the lights.
Did you do any sort of disaster recovery, like backing up the DB, anything like that?
Yeah, so one of the reasons we did pay for Turso was because they do kind of handle this in the background for you. So they do have automatic syncs and checkpoints. With the free tier, I think you will only have one every day or whatever. But also you have to consider, again, it's just a file. So in theory, if you wanted to, you could just take that database file, text it to someone because it's so small, and use it. But thankfully, Turso does handle that, and it has checkpoints. I think they recently added branching as well, so it has all the fancy stuff that you might see in Postgres and stuff. But they handle it for us.
Thanks.
All right. Got another over here.
Oh, that's going to be the difficult one now.
No, I was just going to ask, did you have any interesting ways of any people trying to inject anything malicious or security?
You need to speak louder. I'm an old man.
Sorry. I said, did you have any interesting scenarios where people trying to like challenge the security of the setup and trying to inject something
day
with
one.
like
From day one, humans are horrible. What is worse is that, again, what I said to the other person before, everyone knows each other there. It's a small village essentially. So we would see from day one people trying to scan like invoices. They were trying to scan. There was a guy who was scanning his badge. And I could tell because we set it up as when someone scans like bogus stuff, we get an error report essentially. I'm not sure if that guy knew, but he gave us like his national insurance number essentially. So I'm like, okay, you are trying to game the system fair, but at least don't be dumb. Someone else was, you know how you can generate QR codes to connect to Wi-Fi? The guy was just trying to scan the Wi-Fi password of the gym. Or no, I'm sorry, I take that back. He also has a shop, and he was scanning the QR code that was given to the customers for his Wi-Fi. So I'm like, okay, now I have your Wi-Fi password, great. The messed up thing is that they would go to the reception area and be like, oh, but I've paid for it. My membership is not working. Why is it not working? And you're like, I can see it that you're just trying to scam the system, bro. Like, stop it. And I think it's even worse when people are, you know them or you probably grew up together with them. Did that answer your question? Sorry. Oh, it's going to be even. All the Manchester guys here are going to just give me a hard
We've come
time.
to torture you. So it can be addictive working with something physical, like seeing something actually in the real world come to fruition. 2 questions. How close did you come to really seriously hurting yourself with high voltage?
No comment. Not going to answer that.
Have you lined up any other hardware, real world, affects your real life projects off the back of this?
Answer to question number 1, no. If you go back to I can make the slides public, but the door has a very big like breaker switch that it's very easy to just kill everything. Obviously, it takes a bit of time to boot and everything, but like obviously everything was shut down. The wiring, so there was one wire that had to go to the door. That was the mains, but that was not done by me or by anyone. Like it was an electrician. Thankfully, take care of it. We don't want to burn anything down. The second question, no, that was my first time playing with wires, and it was extremely, extremely rewarding, as you said, because it's this instant thing that you see it not working. You're like, oh, I can try this. The picture I had over there is the only picture I took with the cable that I made. It was a horrible cable. Like it was supposed to be more twisted than it was supposed to. And then, obviously, the more you do and the more you learn, you go like, oh, I need to put those connections in to make it safer and reliable and stuff like that. I would 100% do it again. I'm not sure if I'm good enough to do it as, I don't think I'm going to be switching to electrical engineering anytime soon. But if I was to wire something in my own house, yeah, it's definitely try it. It's for sure addictive. Like it's, yeah, like don't let me anywhere near your mains, guys. Yeah.
Right, we got any questions over the other side of the room?
It's just this side that was interesting.
Gotcha.
These guys were waiting for it for like months now. They're like, we're gonna just grill George.
Hi, thanks. You talked about keeping the database on the edge. Is this loud enough? Yep.
Yeah.
I'm trying to work out where it's being written from and what's reading it exactly. So you have this one writer that's running, that is the backend that's running on the cloud. And then also the door itself is reading a sort of copy of the database. Are there any other accesses, or is it just those two?
Not in this instance. There's another reader, which is a cron job that essentially goes to that database and checks if your membership is about to expire, and they will send you a notification. But in this version of the app, or the platform, whatever you want to call it, is a single writer, and then everyone else is a consumer. And and that's why we're happy to just have the eventual consistency if you want. Mm-hmm. But you can read your own rights. So if there was more, if I was to split this into like a microservice architecture, you can have like multiple databases essentially for every instance of the API or the microservice. And once you write, you can read your own thing. So.
Yeah. Okay, thanks. Actually, follow up on that, because you put a lot of points in that you specified. You could split it up here. You know, I made it so that you could do that. Did you end up splitting up any of it in the end, or did it all just work fine?
No, that's a great question, and that's maybe something I should have spoke about more. The API, that's the main, I guess, place where the load happens, because everyone interacts with it, even if you're a member or an admin. I think for the 2,000-ish members that we have, plus maybe 3-4 admins just running the application, we don't go over like 10-15%, like say CPU usage at any time. So the monolith seems to be okay. There are a few fail-safes, like if something goes bad and it dies, I think Fly just gives you, it's like this Kubernetes thing that if you die, like it brings it back up if something goes bad, if something bad happens. But the monolith, again, popular opinion, seems to be working fine. Like, yeah.
Hi. Thanks for your talk.
Hi.
Once you deployed the project, did you have any big failures, and how did you resolve them?
Sorry, you have to speak up a bit.
Any big failures, anything that went really wrong that you had to then address, and how did you resolve the issue?
Yeah, sure. We had a couple of instances, not on the API specifically, or the Go code, the web app, the Next.js app. For some reason, cookies behave differently on local than on the on the production thing. So I had to kind of rewrite on the spot how the cookies are used there. So that was annoying because no one could log in and they didn't know. The API, thankfully, has been very robust and no major issues. I'm trying to think. I'll come back to you. I'm sure we had like a downtime, but it wasn't something necessarily that a deployment or something caused, which is crazy to think about. Yeah, sorry.
Okay, next question.
Thank you. Hi there. So you said you deployed with Fly.io. I believe it also offers like a synchronized SQLite database,
Yep.
but you then chose Turso, which I hadn't heard of, and I'll have to look into. I just wondered if there was any reasoning behind there, given you already use Fly.io.
It felt that the barrier of entry to Turso was a lot easier. It felt like the managed SQLite of Fly.io. How do they call it? I can't remember the name. They have a name for it.
LightFS?
Yes, LightFS. That, like the way they were presenting it, it was like another like mount on your machine, and it does quite a lot of the stuff that Turso does. But the nice thing with Turso was the dashboard that you can see, like you can edit the rows on the fly. So they have this management dashboard if you want, and it felt a lot more user friendly, and it felt a lot more. The the barrier to entry was a lot lower because I cared about speed and trying to get this thing out of the way. And Turso was just nice, especially, and then again, the killer feature for me was that it could sync on the edge, I guess, automatically, if that makes sense.
Okay, yeah, I'll look into it for my next project. Thank you.
Yeah, definitely try it. Again, not sponsored. There's one over there. Like, yeah, I mean, if I think Gabriel is the guy who writes it, just give me a text.
Yeah, so it's really interesting to see how essentially your constraint, drove your design, especially, the limited internet. If you were to do something similar where it's, small business, you want to do it for free, but you have, it's a different place, you have good internet, would you change something fundamental in your design, you think?
I think I would, I'm not sure if I would, I mean, obviously you would have to change stuff depending on the context of the application as well, but I would definitely take more time to understand, the requirements that they need. Like, it was very difficult for us to just, because every time you asked them or you spoke to the people running the gym, they would just say, we want an app, and they wouldn't understand what we're telling them. Well, you need more things around it to be able to support this. So definitely understand the requirements 100%. But in terms of tech, I would maybe, again, depending on the scale, I would love to explore how this monolith can be broken up more efficiently. And maybe, you might have two monoliths running half and half the services. But I think that would definitely be something I would love to explore. And I would definitely, again, keep trying SQLite. I'm sure obviously there are limitations with a single writer and stuff like that. But yeah. Hopefully that answered the question.
Good, thanks.
Next question.
One more? No?
Hi.
Hi.
Great talk.
Thank
Did you have to do anything around the QR code generation, and how did you handle the QR codes as part of the design? Did you need to encrypt the data that went into the QR codes? Were they like short-lived tokens? Did you have to rotate them? Any information about that would be great.
Yeah, this is a great question, and this is I think a whole different talk maybe of how you actually secure those QR codes. The first version, when it was deployed, again, let's get it on the ground, it was just raw data. It was just this raw JSON thing, which was the membership ID and the member ID, which obviously is not ideal because in theory, someone can generate enough QR codes to try to game the system. The reason we went with this initially was because there's always someone on the reception and they can see sus activity. So that was okay-ish to begin with. Then just hashing not hashing, essentially a one-time pad when creating the password. So we know the key on the door. We know the key when we generate the QR code, we can decrypt it essentially. But, and this is what it is kind of now. Again, not the best, but there's no raw data there. So that was the main requirement. But I'm definitely looking and exploring solutions of how do you do it for, say, for each member. So maybe you can sign the QR code with everyone's password and stuff like that. And how do you make it so that it doesn't leak data, because you don't want people to know what's there. In terms of timestamps and making sure that that's a legit QR code, no, only because memberships expire eventually. So I didn't want to spend more time implementing another fail-safe there. And also, again, because there's people in the reception at all times, it's easier to spot weird or bad behavior. But once I get around, finding a more efficient and better solution to signing those keys, those QR codes, I think definitely a timestamp, a rotating key or something. Yeah, 100%. But again, this one was a bit of a cost over, how fast can we ship this, given we have the protection of someone being on reception at all times. Hopefully it answered the question.
Thank you.
But if you have any good ideas of how to do it, I'm all ears because yeah.
All right, next up. Anyone else? Okay, a big hand for George, everyone.
Thank you. Thanks.